This is video 1.3.2, radicals, and the goal here is to continue to understand how to simplify radical expressions. We're going to pay close attention to making things proper and additional steps that you'll have to take to do that. So let's take a look at the first example. So just a little bit more height and more stuff going on, but this should be getting easier with more practice. So a couple of things to remember, this -3 out in front, you can just kind of let them hang out in front as you start to separate your radicals, because we're going to separate this as 24 square root of a to the fourth, square root of b squared, and square root of c to the third. So taking this one step at a time, the 24, remember we separate that by breaking it into its prime factorization, thinking of it as 2 times 12, or 2 times, and that's 2 times 6, and again the 6 can be 2 times 3. We look for our pairs because that creates a perfect square. That creates the square root of 4 times. These two do not have a pair, so they're going to be left in the radical as square root of 6. So we're going to be left with 2 square roots of 6. So my answer starts to become this -3 times this, 2 square roots of 6, times, and then I have to wait for the rest of my results on the other pieces. So let's take a look at this next piece. Square root of a to the fourth. The square root of a to the fourth. Well, let's remember a to the fourth really just means a times a times a times a. You probably don't need to do this, but what you need to recognize is that when I take the square root of this times the square root of the next one, it really just ends up being a times a. Another way you can think about it, of course, is a to the fourth is a squared times a squared. And we know the square root of each of those is a. A couple of ways to think about that. But this should be getting quicker as you get practice. So now the rest of my answer continues. Now I have my 2 original numbers times a times a. Now we take a look at the b's. Well, that one's easy because the square root of b squared is just b. So I have a times b. And then, of course, times the square root of c to the third. Well, remember c to the third can be thought of as c times c times c. We have a pair of c's, so this will result in the square root of c squared times square root of c. And square root of c squared is c times the square root of c. And that's the final 2 pieces of my final answer. So I have all these pieces, I kind of just need to rearrange them and make sense of them. One thing I'm going to do is I'm going to make sure that I put the square roots together. So in my square root will be 6 c's. And on the outside I'll have -3 times 2, or -6. A times a, which is a squared. And then times b times c. So b, c. So my final answer is -6a squared bc times the square root of 6c. So just lots of steps. A lot of what I write down, you may do some of this in your head as you get better at it. But definitely write things down until you get the hang of it. We don't want to be slowed down by this later in the school year when we're going to needing these skills to move swiftly through certain harder concepts. Let's take a look at example 2. So now we're dealing with the fractions. So we talked about a fraction one yesterday, and you saw some in class as well. But let's think about, remember, this is pretty simple. Square root of 2 and square root of 5 are very simple numbers, but it's really the fact that it's in the denominator. That's what makes it improper. So the fact that this square root of 5 is in the denominator is what causes the issue. I cannot have square roots in the denominator, so remember the trick to getting them out is simply to multiply by a clever form of 1. We're not changing the value of the fraction, we're simply changing the look of the fraction. And by multiplying by square root of 5, on the bottom, we are left with 3 times square root of 25. Which was the whole purpose, because 5 times 5 is 25. But we know square root of 25 is 5. So this ends up as 3 times 5. That's why it's so nice. My denominator becomes a nice, easy 15. The numerator, if you do the same process there, I'm going to put the times the square roots together. The 4 hangs out up front. The radical becomes square root of 10. I want to think about 10 and whether I can prime factorize that and pull any squares out, but I can't because it's just 2 times 5. There's no pairs. And I'm left with 4 square roots of 10 on top. and that's as simple as it gets. I want to check and make sure there's nothing I can simplify. 4 and the 15, you want to check and see if you can simplify those two fractions, but they cannot be simplified any further. And the square root of 10 is inside the radical, so you can't simplify that either. So that's your simplified answer, 4 square root of 10 over 15. So again, fractions, we want to get the radical out of the denominator. This final example kind of draws on just being more careful because of it's slightly different. It's got some subtraction in it. But remember, it's not the numerator that's the problem, it's the denominator. So we do not want the square root of 17 down here. It doesn't matter what's on top. We can't have a square root in the bottom. So we're going to times by the square root of 17. So on the top, I'm going to have square root of 17 times each of these pieces. And this is where I'm mentioning this is a harder problem only because we got more to keep track of. So we're going to end up with negative 3 times square root of 17 minus square root of 2 times square root of 17. Well, that's going to give me square root of 34. 2 times 17, 34. All over. I'm going to do the same thing on the bottom. I'm going to multiply, but this is all a multiplication problem, so it's just going to be 3 times the square root of, I'm going to multiply these two pieces together and put them in one radical, and I get 289. And maybe you could skip this step because I know the square root of 289 is 17 because I just did 17 times 17 to get that answer. So this can simplify further into negative 3 square root of 17 minus square root of 34 all over 3 times 17. And one last step, I can actually do the 3 times 17, and I'm going to get 51. So this is your simplified answer. It kind of looks bigger, got bigger numbers, but it is proper, and that's what we'll be looking for in this course. You're going to see proper answers given on standardized tests in the math world, so it's important to get prepared for that and be ready to give proper answers when it comes to radicals. So here's your checkpoints. Today you have 2, and what I want you to remember is that there is a Google form that you have to complete for your checkpoints. So remember, you're going to go to the Kennedy Webstar website for our class, and under your videos, you should see a link, a live link, to click and enter your Google form. And that'll allow you to enter some parts of your answers so I can get some feedback on how well you did with this stuff. So here is the Google form that you'll fill out. It's pretty simple, but please make sure you fill that out. If you need to use a computer right at the beginning of class, do that. Here are those questions for that. So hopefully you got the checkpoint questions down, and then these are the questions that you'll be asked in the Google form. Always remember to hit submit after you enter a Google form. It's always at the very bottom of a Google Doc. So make sure you actually enter that when you are working with Google Docs. So bring in your questions and your solutions to your checkpoints, and we'll see you in class tomorrow.